Hi there, it's Mark Dumas again with another episode of Laboratory of Irreproducible Results. This is episode 8. In this episode, we're going to give an old 3D printer a new life. What we're going to do is replace the printhead components from a PrintRite CoLiDo 2.0. Now, these parts were okay in their day. It's about a 5-year-old printer, but progress has happened in the 3D world, and rather than just replace this particular printhead, I've decided to print a bracket for a modern printhead and populate it with parts that are a little bit more upgraded. So here's what I've got. It's a 3D printed bracket in 2 pieces. It holds a geared extruder and motor. It's got a E3D V6 hot end in there, complete with a custom mounting location for the heat break fan. It's got something really important that the old printhead didn't have, and that is a part cooling duct and fan that's built right into the printhead. Okay. I've even put in a little translucent window with some LED lights so that it lights up the area that's being printed. All in all, I think it's a much better printhead than the original, and I'm hoping that this gives that printer another 5 years of life or so. So first of all, let's go take a look at the printer. This is a PrintRite CoLiDo 2.0 Plus 3D printer. It's got this interesting case made out of clear plexiglass. I didn't find a whole lot of information on the internet about it, so I don't think it was an incredibly popular printer, but I did notice that it was very similar to a printer made by Flash Forge. The rectangular build plate, the kinematics, the location of the motors and arrangement of guide rods and everything is very similar to that printer. So there may have been some genetic transfer between those companies. Maybe one sold their design to the other. I don't really know. This particular printer was headed to the trash. The previous owners, I think, were having print head problems, and had had enough and were throwing it away. Someone said, "Hey, Mark might like this thing for parts," and so that's how I ended up with it. When I got it, I noticed that, all the motion control stuff is in good shape. The controller works. It was just that printhead was in non-working condition. So that's when I decided, rather than scrap it for parts, to actually rebuild it. So what I've done is strip it back to just the bare carriage. This is what I have to work with for designing the new printhead. It's kind of a square piece of plastic with a couple of mounting bolts from the bottom and an opening in the middle here. Where the stuff has got to fit. So that's the design constraint on one end, and of course all the wires are going to connect to the top. So let's take a closer look at the old printhead parts. So these are the parts from the old printhead on that CoLiDo printer. Again, it was disassembled when I got it, but I kind of see how it all fits together. The backbone of that printhead was this rather heavy metal bar. The hot end would have mounted through here like this. The extruder motor would have gone over here somewhere. The extruder back plate would have been in there like that. And then the lever for pinching the filament is here. I don't think I have all the parts. Obviously the spring is missing. And then let's see, there was a little circuit board for making all the connections, and then some sort of cover, I guess, that goes over here. At any rate, I decided not to rebuild this design, primarily because of 2 deficiencies. Even if it was working as well as it was originally designed, there would be no part cooling. So there's some add-on things you can do out there on Thingiverse, but I kind of wanted to build that in an integrated way. Also, you'll notice there's no fan on the heat break area, so heat from the hot end could, I think the intent was that this bar just, sinks that heat up away somewhere, but heat can get on up into the top part of the hot end and cause the filament to get a little soft too early, and that can contribute greatly to printer, to filament jams. So for those reasons, no part cooling fan and kind of old-fashioned parts here, I decided to set this aside and kind of start from scratch. So this printer, just as a side note, was built in 2016. I found a date code on it. And today, Today we're at early spring of 2021. So this is a 5-year-old printer, which may not sound very old, but the 3D print world is moving very quickly, and there have been a lot of improvements. And I just feel like with a little bit of help of having a new design, we can kind of set this aside and get a lot of new life out of that printer. Now, so here are the parts that we're going to replace that with. Here's our more modern geared extruder mechanism, and it's going to be driven by this motor. You'll notice this stepper motor is a little thinner than the original. That's so that there's no, otherwise there would be an interference problem with that plexiglass case on the CoLiDo printer. Plus, since this is a geared extruder, you don't need as much torque from the motor, so that's going to work fine. And then this is the E3D hot end, and this comes with a fan that is intended to be mounted to this little plastic clip-on duct here that goes over the fins of that E3D, but I couldn't figure out how to make that work, so we're just going to toss that piece and just reuse the fan on a custom printed part. And obviously we need a way to hold all these parts together and fit them into the space constraints of that CoLiDo printer. And so this is where I spend all my time and effort, is coming up with this design that's 3D printable to hold all the parts together. Let's see. This is available on Thingiverse. I'll put a link in the description below. It is a 2-part deal here. Let's see. You do want to print it upright, like it's used and like it's presented in Thingiverse, which will require some support settings to be on. That all comes off pretty easily. In order to not get too much support material down in the nozzle area here, I found out that in Cura I could set the overhang angle as high as 60 degrees, and that resulted in only a little bit of support material that could be pried out from the outside here with an X-Acto knife. You might have noticed the two-tone color scheme on the fan shroud part. That's because of a feature I haven't talked about yet, but I liked having a little bit of light on the nozzle area of my printers. So I've put some little pockets in here that allow you to put in 2 of these high-intensity white LEDs. And in order for that light to come out around and illuminate the print nozzle, you want to print with some clear PETG first and then switch over to your opaque color after that. Let's see what else. Oh, I'm using some brass melt-in inserts for the mounting area on, where the screws from the CoLiDo carriage retain the bracket here. These are pretty cool. Here's one that hasn't been used yet, but you get a whole kit of these things, different sizes. I'm using a 3mm metric nut here. I think it's 5mm in diameter and maybe 3mm deep, although you could probably get away with another millimeter. The way these work, just briefly, there's lots of YouTube videos out there, but I've got a little pocket built into the 3D part. You slide that into position, then you take your hot soldering iron, hold it lightly on the top of that brass insert, and it'll melt right in like that and form a nice threaded part for you. Now, if you don't want to mess with that, I think you could probably just drill the holes out for a little 3mm screw to come up through there, and then put a hex nut on there. That'll probably work, although I haven't tried it. Okay, let's see. So this is the overall design. Again, the most important thing I feel like I'm getting here is the cooling duct. And then beyond that, I'm getting fairly modern parts that should allow this thing to work very reliably with few jams and, really nice print quality, easy to find replacements. You might be thinking, with those new features added, what's the weight difference? Well, on the new one, it's 280 grams. The old one over here was 420 grams. So yeah, we're getting a pretty good weight reduction as well. So that generally means you can swing that head around a little bit more and not affect print quality, faster prints. So all around, I think I'm getting a good, a good trade-off here. So let's put this thing together. The order is actually, it's not difficult to put together, but the order is pretty critical because there are some blind screws and some things have to go in before others, or you'll end up having to back up and disassemble and reassemble. So you want to start with putting the part cooling fan on. And again, that's just one of these little 30 by 30 millimeter by 10 millimeters thick fans, just like the one that's used on the E3D hot end. I'm using some little sheet metal screws just to go right into the plastic. There's no need to tighten these any more than just a little bit more than finger tight. At least I haven't found any reason yet. And that goes in like this. I would also recommend that you have the wiring come off to the left-hand side like I've shown here, just for wire management. That'll make more sense here in a minute. In fact, let's go ahead and poke that connector through that little opening there. Okay, now the next piece is to go on is the motor for the extruder and the back shell of the extruder mechanism. Now I like to put the wire connector off to the left side on the motor, again, because that's where all the wires are going to come together here. It's just a little bit nicer for routing the wires. And then we're going to put the back shell of the extruder on here. Now, there's two things I'm looking at when I put this on. One is I want the teeth on this little gear on the motor shaft to mesh with the teeth on the big wheel that's on the extruder. And then there's this one little screw in here that we're going to attach into that hole. And the reason you can't put the hot end in first is because it covers up that little screw hole. That's kind of a questionable design choice in my book, but that's what we're dealing with here. At any rate, so this thing typically slides on pretty problem-free. And then you have to fish around in there and find a way for that to thread into the motor body. Okay, I've got something not quite right. Okay, and again, there's no need for that to be, any tighter than just a little bit more than finger tight. And just a quick check to make sure that when you turn the big wheel, it's turning the motor shaft. You can feel it cogging, so that's all in there good. All right, now we're going to put in the hot end. I've already got this one, wired up and kind of ready to go. There's this little guide tube on the end that is critical for, especially if you're printing with flexible filaments like TPU. This has got a rounded side that's going to fit into this top slot there, and then this top flange on the machined aluminum part of the hot end is going to go into the next slot down. And I like to have the wires come out the back and the kind of the oblong end of the heater block off to the right. And it's a little bit of a tight fit getting around the nozzles for the part cooling ductwork. But if you just sort of wiggle that part into there, and then that part into there, and then just about the time you're ready to get frustrated at it, just lean on it a little bit and it'll go right in like that. Okay, so what we want to check for here again is make sure the wheels are not bound up. We've got the plastic nozzle piece right up there where the filament's exiting the drive wheels. We've got the heater block kind of off to the right, and then that means the wires come off the back. They're going to need to get routed right up into this area there. Okay, so that's looking good to me. All right, next up, we're going to put the shell top cover on for the extruder. Remember that this is another hinky design choice in my book, but there's 4 screws, but this one that's kind of off is the shorter one, okay? So you just need to kind of jiggle all 4 of those screws into position. The 3 long ones, of course, are the ones that are going all the way through the extruder mount and into the motor. So this is really what's holding the bulk of the part together. And if we're lucky there, we can get these things started. Okay. Now, again, I like to put these on just a little bit more than finger tight. All right, so that's actually the hardest part right there. Next up, we're going to put the fan and LEDs in. I've already got the LEDs in. Obviously, I didn't want to unglue them from their position, but again, this is the 30 by 30 millimeter fan that came with the E3D hot end. I'm just using some little, I don't know, sheet metal screws, I'm not sure which, to hold it in. I do recommend tacking in with some glue the LEDs here. Now you'll notice that I've got some black heat shrink tubing on the wiring, the wire that's coming out of the LED. That's where the current limiting resistor is for the LEDs. So they're wired up in parallel to 12 volts. And then the resistors in series with the LED. I figured for the LEDs I'm using that I needed about a 620 ohm resistor in each leg of the LED. And then I like to route the wiring here such that it's not blocking the airflow as much as possible. And then I route the wires for the LEDs through that little notch in the case right there. Then we can put in the 30 millimeter fan. And you want the wire coming off to the side right up next to where the wires are exiting for the LED. And let's see here. Somewhere I've got a screwdriver for these. And again, I'm just screwing these sheet metal like screws right into the plastic. I've got little guide holes built into the design for that purpose. No need to go extra tight on that. And as with the fan on the part cooling fan, you want to make sure that the way you've got this wired up polarity wise is drawing air in the right direction. Here we want fresh air coming in from the front of the printer. It's going to drive it through that opening and then across these fins on the hot end and then out the back. So let's go ahead and snap this part in. These long ears go around the cooling fins there. It's a little bit of a snug fit, but if you get that lined up just so, that should slide on a groove all the way back. Might get a little click as it goes into place. If not, you can turn it around here and just push those tabs out. That's all that I'm using to hold that in place, no other screws. So again, we're blowing air through here, down around the fins of the hot end and out the back. Okay, let's see. I think that's about it. Yeah, let's dress up these wires a little bit more. Again, I'm going to push the wires through this little opening here to keep them from flying around too much when things are actually being printed. And then I'm going to show you, so then I've got a wire tie here just to kind of help things stay tidy. Now, in the next part of this video, we're going to hook this up and run it. It's going to be a little harder to see what's going on back here, so let me just show you. This cylinder right here, split cylinder, is where the wires that come from the controller on the CoLiDo slip through, and then the spiral wrap slides inside of that tube, and then we're going to use a wire tie around the top of that tube to kind of mechanically connect the tubing here with the spiral wrap so that we're not binding up wires and causing a lot of flexing on the actual wires. And then we're going to hook up those wires to all of these wires. And then I have one other slot back here that's going to be hard to see in the next part of the video, right in there. That's for wire tie as well, so that you can kind of bundle up these wires in the back and again, keep them kind of tidy. So there you have it. This is the new, more modern print head for the CoLiDo 2.0. Let's go put this thing in. All right, let's hook this thing up. I like to start by hooking up the wiring first, and then we'll mount it into the carriage. Let's start by putting the wiring bundle from the control unit onto the print head. Let's see. So what I do is line up all these wires into kind of single file and feed them through the slot in the side of the cylinder here. Not sure if I showed that very well earlier, but that's how that works. We're going to just line them up and feed them through broadside like that. Okay, and then we're going to slip the spiral wrap into the inside of that tube by a little bit, say, I don't know, 1/2 centimeter or so. Okay, kind of like that. All right, then we're going to use a wire tie around the top of that cylinder to kind of clamp around the spiral wrap. And what we're trying to do here is provide a good mechanical interface between the spiral wrap and the cylinder without crimping any wires. This is where all the motion happens when things are printing, and we don't want to be bending pinched wires back and forth any more than we need to in order to prevent wire breakage. We'll just clip that off there. Okay. Now what we're going to do is hook up all the wires. Your connector scheme may be a little different. I know it looks a little bit daunting here. Let's start with the stepper motor. I've got a red wire and I've got a red dot to remind me which way that goes together. And let's see, we've got some fairly heavy gauge wires for the heater block. And don't laugh, but I'm still using some prototype wiring here. I just have some pins soldered to the heater block that I'm going to push into here. Polarity doesn't matter. I've never figured out if I didn't get the polarity right, the hot end doesn't get cold. Okay, just joking. Okay, then we're going to hook up the thermistor the same way. Let's find that connector is right here. Again, polarity doesn't matter, so we'll just shove these pins in like that. Okay, now the remaining things on the print head are on these connectors right here. It's the fan for the part cooling, it's the fan for the heat break, and it is the LEDs. Now all of these I'm going to just power up directly off of steady 12 volts. And so coming from the control unit, I've got a pair of 12 volt wires coming in that I've put 3 connectors on. So it doesn't really matter what order I put these in. They're all the same as long as I get red to red and black to black. And I've got these little polarity correct connectors that keep me honest there. There's the second one, and that's the third one. Okay, so that should do it. Okay, next up, we're going to dress up these wires just a little bit. In the back, as I reminded you earlier, the heater cartridge wires and the thermistor wire need to come up pretty close to this little corner area so that there will be clearance when this whole thing drops into the carriage on the CoLiDo. And then other than that, we're just going to try and dress up these wires as neatly as I possibly can. And then I'm going to take another wire tie, and remember that little slot that I provided on the frame down here, which you can't see now, but I showed you earlier. I'm now going to attempt to fish, I'm going to attempt to fish a wire tie through that little slot so that we can just hold these wires all together in some order of tidiness. Okay, I think that will work. Clip off that wire tie. Okay, now we should be able to mount this. Again, we've got a rectangular base that I've designed into the mount. We'll drop right into the carriage on the CoLiDo. I've got various little protrusions and tabs that should match up with the similar design on the carriage. We've got two 3mm screws that you have to screw from the bottom up. Another questionable design choice there, but this thing should just drop right in, just like I said. And the problem here again is the wiring. Okay. Okay, some of those wires got loose, but it still looks all right. Okay, then we are going to drive the screws in from the bottom up. A little hard to see them, so I like to use a little mirror from the bottom, so I can guide my hex nut driver. And once again, my guidance is not too much past finger tight on these is fine, because of all of the slots and so forth that this part makes use of on the carriage. Just a couple of screws is all it really takes to hold this thing in there nice and secure. Okay, and let me come back over here and try that one more time. That feels good. Okay, so we've got it all mounted in there. Everything slides back and forth. One thing you can't see from that angle is the homing switch for the x-axis is over here. There's a little pad I've designed into the frame right there that should align with that and click that switch when it homes. That's one good thing to check. Another thing we can check is to turn on the power, and after a few seconds it should come on. Okay, and we've got a little bit of a loose connection on the LEDs somewhere. Okay, and after just a little bit of fussing around with some loose connectors there, both fans are running, and the I think you can see a little bit of LED light on under there. Okay, so we're ready to print, right? Not exactly. Let's go back to the workbench and go over some additional setting changes that are needed. All right, so we've made a pretty dramatic change to the print head on this printer, so it stands to reason that there's going to be some settings that need to change. First of all, our E-steps, hot end PID settings, and the nozzle offset settings. These are all things that I would like to have changed in the firmware. You can hook up a terminal to the printer and change these and commit these to EEPROM on most printers. I found that that did not work on the CoLiDo, so either that function's been disabled or there's no EEPROM. I don't know what the problem is there. So I have found a workaround here that's actually quite simple, and that's to go into the slicer settings. Now I'm using Cura. I'm hoping that if you're not using Cura, you can find similar settings there. So here's how this works. Go into Cura, find the Manage Printers drop-down menu, select your CoLiDo, and then select Machine Settings. And that's going to bring up a window that has two tabs. It should start right up in the Printer tab. And you want to find a window that says Start G-Code. Okay, this is the code that's going to get executed before the printer, before the G-code that actually tells the printer, where to start squirting material to make your part. So there's going to be other stuff in that little window. There's typically some code to home the head and prime the head with a little bit of by moving some of the some material through the head. And what you want to do is put these two lines in at the beginning of that window. So M92 tells the printer how many stepper motor steps are required to advance the filament 1 millimeter. And when you think about it, the old extruder had a kind of a direct drive sort of extruder. The new one we're putting in is this 3-to-1 gear ratio tightened extruder. So you actually have to spin that motor a lot more in order to get the same amount of material coming out. So there are methods documented on YouTube, if you want to go find it, that I use to get this 400 steps per millimeter. But I think if you just plunk these numbers in, that will get you really close, if not perfect. Okay, then the second line is this M301. This is the code that sets up the PID parameters for the E3D hot end. So PID is an algorithm for the controller to control the temperature at a nice steady rate of that nozzle, how quickly it responds to changes in temperature, how hard the power is changed in order to get to the target temperature. And there are YouTube videos that you can run to help you optimize these values, but I think these will get you pretty close. So the P parameter for proportional coefficient is 150.41. The I, or integral coefficient, is 12.34, and the D, or differential parameter, is 477.0. Okay. Now, while you're in Cura, click not on the printer tab, but on the extruder 1 tab, and look at the nozzle offsets for X and Y. So in the new design, I was able to line up the tip of the nozzle exactly in the same at the same Y coordinate as the old design. So you just make sure that's still 0. But the X offset, I couldn't exactly match the original design, so to override the firmware in the control unit, you'll need to change the nozzle offset X to this minus 35 millimeters, and that'll ensure that the nozzle lines up. If you want a full bed print, then you're going to need to make sure that the firmware knows exactly where the nozzle is relative to the bed. All right, second area. The thermistor in the old printer is not the same thermistor type that's in the new one. And I tried to find out more about the old thermistor so I could replace put that one in the new print head, but I could not find anything. So in a nutshell, I'm basically telling Cura, I'm basically lying to Cura about the temperature I want, depending on what kind of filament to use. So for example, I typically like to print PLA at 210 degrees C, but in order to get to that temperature, you have to tell Cura to tell the printer to go up to 240 degrees C, and that'll actually result in a 210 degree printing temperature. Similarly for PETG, I like to print at about 245, but you need to tell Cura to print at 255 in order to get to that temperature. And for TPU, the flexible filament, I like to print at 235, and you're going to have to tell it about 250. Again, if I could get into the firmware of the CoLiDo printer, I might be able to tell it to change that, but just didn't get to it on this part of the project. Okay, and then finally, you probably noticed when I was hooking things up that this brand spanking new part cooling fan is hooked up to 12 volts all the time. Anytime the printer is on, the part cooling fan is on 100% of the time. That's not ideal. Typically, you like to print the first layer with the fan off and then bring it on maybe to 100% if you're printing with PLA for the rest of the print. I find for PETG or ABS that you don't really need a full power fan on. But although I was able to find some pins on the CoLiDo controller board that said part cooling fan, or at least indicated that's what they were for, it turns out that the control unit is not actually controlling those pins with the firmware. So the result is right now the part cooling fan is always on. I haven't had any trouble with parts sticking to the build plate. The print quality is always better than with the old printhead that didn't have a part cooling fan. So on this one, I've chosen just to live with this until at least such time that I either update the firmware or change out the controller on this printer. All of these things are things that I could address if I had access to the source code. Until recently, I didn't think there was any available. I'm finding that someone has provided a pointer to source code that I might be able to go in and change and fix at least most, or if not all of these things. So I'm not going to get to that on this particular YouTube video, but maybe we'll follow up with that. In the meantime, I found this to be a fairly effective set of workarounds. All right, so here we have the new printhead assembled, mounted up to the printer and happily printing away. You can see both fans and the light are on. Let me reposition it here where we can watch it actually print apart for a different project. I'll zoom in a little bit there. This is just a little doodad that's going to look like this when it's all done, and it's going to be in PLA, obviously. This has been a major improvement on this printer. I have been using this printer off and on for about a year now. It's April of 2021, and it's been a really reliable printer since I made this printhead upgrade. I don't use it every day, but when I have a lot of things going on, it's regularly pressed into service. During the onset of the pandemic, for example, I had all my printers, including this one, running at least 18 hours a day printing out frames for COVID masks. So it's been great. If you've got comments on anything, questions about what I've done, or things I should have done differently, I'd love to hear from you in the comments. Please like this video if you got anything out of it, and subscribe to my channel if you like. Have a great day and keep on making.